In this video, we're going to talk about reflections. A reflection is when a shape called a preimage or an object, it could be any object, is flipped over a line called a line of reflection. I like to think of it as being flipped over the line. You can think of it as a mirror image. There's a visual over here so you can get a better picture. We have our pre-image triangle ABC, and it was flipped or reflected over this line of reflection K to get the image A prime, B prime, C prime. Notice that the distance between each of the points in the pre-image and the image are equal distant from the line of reflection. And that's going to be important when we are doing reflections. The pre-image and image points should be equidistant from the line of reflection. So, a couple of things about reflections. They are rigid motions. That means that the image after a reflection will be congruent to the pre-image. Since reflections make congruent figures, we know that when two figures are congruent to each other, like triangles, they are exactly the same size and shape. So that means all of the corresponding sides are congruent to each other, and all of the corresponding angles are congruent to each other. So since a reflection is a rigid motion, it preserves side lanes and angle measurements. The original figure and the image after the reflection will have the same side measurements and the same angle measurements. Reflections do not preserve orientation. That means the way the object is facing. Notice how after this triangle was flipped over the line of reflection, it's facing a different direction. It's oriented differently. Same figure, it's just oriented a little bit differently. Okay, so we're going to take a look at this first one over here. Let me make my coordinate grid. Okay, so I made my coordinate grid and I just graphed the 2 points in the question A and B. And it's asking us to find the coordinates of A prime and B prime, which are the images of points A and B after a reflection in the x-axis. So remember mirror images. When you're doing a reflection, we want equal distances on both sides of the line of reflection. The line of reflection is the x-axis, so that's this axis. So what I'm going to do is I'm just going to count from point A to the line of reflection, and that's 2 spaces. And I'm going to move it an equal number of spaces to the other side of the line of reflection. I'm going to do the same thing with point B. 1, 2, 3, 4, 5, 6 spaces from the x-axis from the line of reflection. 1, 2, 3, 4, 5, 6. Here it is, 6 spaces on the other side of the line of reflection. So that would be the point A prime would be the point 0, -2, and B prime would be the point 1, 2, 3, 4, -6. Okay, let's set up the next one. Let me move this so you can see the question. Okay, so I just made my XY coordinate plane and I just graphed the points of the triangle mentioned in the question. So here we have triangle sun. And what we need to do is graph and state the coordinates of triangle S prime, U prime, N prime, which is the image of triangle sun after a reflection in the Y axis. So this time our line of reflection is the Y axis, which is this axis over here. So this point S, is already on the line of reflection. So that means it has nowhere to go. It's already 0 spaces from the line because it's on the line. So that means it's going to stay in exactly the same spot. So here we have S prime. It has nowhere to go. It's already on the line of reflection. Okay, point U is 1, 2, 3 spaces from the line of reflection. So 1, 2, here would be another 3 spaces. That would be U prime. And point N is 1, 2, 3 spaces as well. 1, 2, 3 would put N prime right here. Let me connect that together. And then I'll write down the coordinates of the points. So S prime is the same as S. That was 0, 6. U prime, 1, 2, 3. 1, 2, 3, 4, 5. Oh, sorry. -3, 5. I almost wrote that down incorrectly. And N prime, 1, 2, 3. So -3 and 0. There we go. Notice how it's mirror images on either side of the line of reflection. Okay, let me move this so you can take a look at the question and let me plot my points. Okay, so I plotted my points and we need to find the image of triangle ABC. So we need to find triangle A prime, B prime, C prime. And it says our line of reflection, lowercase r means reflection, if you see that. Capital R means rotation, lowercase r means reflection. Our line of reflection is the line y equals x. So just a quick refresher from Algebra 1. The equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. When you don't see a number in front of the x, that means there's an invisible 1 there. So that means the slope of this line is 1. And since we don't have a y-intercept, that means the y-intercept was 0. So that means the line y equals x passes through the origin because its y-intercept is 0. That's where it hits the y-axis. And it has a slope of 1. So to graph a slope of 1, up 1 over 1, up 1 over 1. I just want to graph the other direction as well so you can see what this line looks like. And here we have the line y equals x. So it is a slanted line, so it could get a little bit difficult when we're counting the spaces from each point to the other side of the line of reflection. So I see here that point A is one diagonal box from the line of reflection. So I want to go another diagonal box to the other side of the line of reflection. And that gives me the point 1, -1 for A prime. Okay, for B, I see that it's also one diagonal box to the line of reflection. So I want to go another diagonal box to get B prime. And let me write down the coordinates. That's 1, 2, 3, 1. And then finally, we're just left with C prime. So C prime's going to the other side of the line. So let me use a different color. So it is okay. So it is like 1.5 diagonal boxes. So I'm gonna try my best to go another 1.5 diagonal boxes. And that brings me over here. And that is the point 1, 1, 2, 3, 4. So as you can see, it can get a little complicated counting diagonal boxes when you're reflecting over a line that isn't just like a straight vertical or horizontal line that isn't one of the axes, the X or Y axes. So we do have some rules to make your life easier when you're doing reflections like this. So I recommend that for reflection over the X and Y axis, you just do it graphically. It's easy enough and count the boxes from the line of reflection. But there is a rule for the x-axis, all you do is make the y-coordinate negative. For the y-axis, you make the x-coordinate negative. But for the line y equals x and for the line y equals -x, since those are slanted lines, it could be really difficult to count diagonally depending on where your points are. If they're not clear points, if you're counting like half boxes or quarter boxes, that could get really confusing. So for these two, I do recommend using the rules. For y equals x, it's super simple. You just switch the order of the coordinates. For y equals -x, you just switch the order and change the signs. If they were both negative, they would become positive. If they were both positive, they would become negative. Switch the signs and change the order. The origin is the point 0, 0. We don't really do point reflection, so I'm not going to talk about that one. That doesn't really come up. Okay, you can do these ones super quickly now that you have the rules, or you can use a piece of graph paper. That's up to you. Please pause the video. Let me just move this one so you can see it. Please pause the video and try them on your own, because if you don't pause the video, it's just going to show you the answers. So please pause the video and try them out. And here are the answers. The only two that were a little tricky is this one up here, because it asked what quadrant the point lies in. So the coordinate grid is divided up into 4 quadrants, quadrant 1, 2, 3, and 4, and they go in a counterclockwise direction. So the point would lie in quadrant 3. This one over here, a little refresher from Algebra 1. When you have a line that's x equals a number like x equals 3, x equals 5, x equals 24, whatever, that's a vertical line. So just like I graphed here, that's a vertical line going through the x coordinate of 3. If it was y equals 3, that would have been a horizontal line going through the y coordinate of 3. So x equals a number that's vertical, y equals a number that's horizontal. So since it was a vertical line, I want a horizontal line because that's what's going to be perpendicular to a vertical line. And the only horizontal line here was the x-axis. The y-axis is a vertical line. X equals 1, that's another vertical line. Y equals x, that's a slanted diagonal line. Moving forward, let's take a second and look at what this is asking. So we are reflecting triangle ABC over the line x equals 1. Let me graph the line x equals 1. So the line x equals 1 is our vertical line passing through the x coordinate of 1. Oops. Okay, so that's our line of reflection. So for each of the points, we're going to count the boxes to that line and move it in equal distance on the other side. Here we have 1 space. Let's move it another space. And 1 more to go. Let me use let me use the same color. 1, 2, 3, 4. 1, 2, oops. My counting was confusing. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay. It doesn't say that we have to state the coordinates. It just says to graph and label. So that is graphed and labeled. So all good to go. Oh, oops. I copied the same question again. Let's forget about that. Okay. The last thing that I wanted to show in this video is how to construct the line of reflection. So over here we have 2 triangles. Oops. Let me move my compass. We have 2 triangles. We have the pre-image triangle ABC and the image triangle A prime, B prime, C prime after reflection. So if you wanted to see with constructions what the line of reflection is, this is what you would do. You would connect together 2 corresponding pre-image and image points. So I'm going to connect together B and B prime just because they're close to each other. A and A prime is like super far from each other. And I'll also connect together C and C prime. And that's enough. You can just do 2 pairs of corresponding pre-image and image points, and that should be a pretty accurate depiction. And since we know that the line of reflection is an equal distance from the pre-image and the image points, what we're going to do is we're going to find out where the middle is between these 2 points. Middle, we're thinking midpoint, we're thinking bisector, we're thinking perpendicular bisector. So that's what we have to do. We have to construct a perpendicular bisector. So let's come over here and let me use a different color for my construction marks. There we go. So I'm going over to one endpoint. I'm just opening up more than halfway. It doesn't matter exactly how much. An arc above and an arc below. I probably should have made this smaller. Probably would have been easier to see. Let me zoom this out so it's easier to see. Okay. Now without changing the distance on my compass, I just made the same arc, equal distance. Let me move my compass away. Right through those 2 intersection points is my bisector. And just to make sure that I'm super accurate, I should also do this for the other 2 points. It should be the same bisector because it's the same line of reflection that it was reflected over, but let's just see. Oops, I keep clicking on that. I want to click on the color. There we go, because I don't want my construction marks to be all confused here. Okay, so I'm going to go over to one of the endpoints on this segment, and I need to make that smaller. That's about 3/4. Doesn't matter exactly. Should just be about 3/4 of the way down. Using the same distance, other endpoint. There we go. And if I connect through the two endpoints, notice how it matches up exactly to the other one. So we found the line of reflection. The line of reflection is the line that we constructed. I just put some arrows on the end to let you know that it's a line. You might have also learned in class how to actually construct a reflection of a triangle over the line of reflection. I'm not going to go over that in this video, but there's some good YouTube tutorials on it if you did learn that in class and you wanted to review it. If you go onto YouTube and type in constructing a reflection, it should pop up and you should be able to find some good videos on that.